These will be the notes for 11.8, mixed expressions and complex fractions. So it's just going to be a mix of different things, and then we're going to have these complicated looking fractions with lots of different things going on. So as we jump into these, you'll notice that nothing is written for the problems, but the first one we're going to do, as we're told to simplify these, is that we have 3 plus 6 over x plus 3. Now, what makes this different from the last section of notes is that we need to put these together, and I know that this could be 3 over 1, but I need them to have the same denominator. So it's like I have an expression that's just a value, and then I have a rational expression, so I'm putting together two separate things. So over here I'm going to write 3 times x plus 3 over x plus 3. Throw some parentheses around there. There's so many different ways you could write this if it really matters to you. Plus 6 over x plus 3. Now that I have the same denominator, I can distribute the numerator of the first fraction, 3x plus 9, and then write plus 6 all over x plus 3. As I go to combine up top, I'll get 3x plus 15 over x plus 3. And our final step always is to make sure that we have as factored of a result as possible, for a number of reasons. 1, perhaps something can cancel out. And then 2, answers are considered simplified when they're in their most factored form. Your textbook might show 3x plus 15 and not have that top part factored. So just know that it's always better to be a little bit more thorough and factor at the end. The next problem we'll do is 6y over 4y plus 8 plus 5y. Now, yeah, you could probably multiply the top and bottom of the right fraction by 4y plus 8 and then simplify it all later. But for me, it often is less work to try to factor at the start. I'm not promising that that's going to be the best decision, but it's the decision I'm making. So here I have 5y, and I'll multiply both the top and bottom by 4 times y plus 2. So that when I go to combine these two fractions with the same denominator of 4 times the quantity y plus 2, and I'm okay doing this right away because I'm not having a negative here, so I think that's an okay shortcut to jump right in. So in the numerator, I'll write the left fraction of 6y. And instead of seeing this as crazy complicated, I'm picturing 5y and 4 as becoming 20y in my head, so I'll write that off to the side just for you to see. And that 20y is going to distribute to the other y, giving me 20y squared. And again, you know, this 20y would distribute to the 2, giving me 40y. Now, I don't have to rewrite anything over here because we have the least common multiple. We're done. Now, we have to combine like terms in the top fraction. So I'll write the highest degree first, 20y squared, and then I'll write plus 46y. All of this is going to be over the quantity 4 times y plus 2. When I look at this, you know, maybe I want to try to take 4 out from both of these terms, because 4 times 5 is what I'm thinking about. But 4 does go into 40, but not 6. So I'm going to try 2 instead. So I'm going to factor out 2 from the numerator, leaving me with 10. But I'm also going to factor out y from the numerator so that I write 10y. And then I'll have just the value of 23 here. And then here's 4 times y plus 2. When I go to simplify things, 2 and 4 cancel out, but I'm left with 2 in the denominator, so that I have y factored out front, 10y plus 23, all over the quantity y plus 2. But don't forget that 2 that was needing to be rewritten. Again, your book might not show this totally factored, but I believe that's the best practice. Okay, so we got 2 examples here. We'll make a third one, and it'll be on your own, and I won't show the result for it. So write down 15 minus 17x plus 5 over 5x plus 10. And once you get to the end, see if you get... So there's the result I got once I factored the whole deal. 58 and 145 do not have any common factors that work out nice. Okay, we'll look at this one word problem before stopping this video and starting a new one. So here's some complex fractions. Baking. Caitlin has 2.5 pounds of cookie dough. Okay, so there's the 2.5. If each cookie requires 1.5 ounces of cookie dough, how many cookies can be made? Well, let's think about that. You know, I can imagine, well, I guess I just divide these numbers. That seems like it will work out nicely. But fractions always get confusing. So the 2.5 is measured in pounds. Now, let me write that neater. LBS. Whereas the other one is like ounces per cookie. So, if I divide the total pounds of the cookie dough available by the ounces, I guess I can, end up with just cookies. But we do have our first problem, and that's that this is in pounds and not in ounces, so I'm going to multiply this by 16 OZ over 1 to get the pounds. But since this is more about introducing the idea of complex fractions, I'm going to jump into the math. Here's 16 times 2.5 over 1.5. And our first problem is that dealing with mixed numbers is a very, very poor choice. We always want to have improper fractions as we move on to actually doing the math inside. So I'm going to convert these to 5/2 and 3/2. Now here's where I really, really want to maybe spend some one-on-one time with each of you guys to see that you feel comfortable with the way I'm showing this. Because I'm going to show this a little bit different from how your textbook might. I do not want to have fractions being divided by fractions. So why not just multiply the bottom by its reciprocal? And then do the same thing up top. I know that in doing that, this fraction will go away. So that I have 16 times 5 over 2 times 2 over 3. Take a moment and try to look at that, and I'll even wait in the video to let you look at it for a moment. Now, it might not click right away, so let's do some more examples later. But if you're like crazy uncertain about where that came from, I'd definitely like you to come and talk to me, and we'll do these the way you feel most comfortable. So I look at this and I'm like, well, does 5 over 3 cancel or have any factors that do? Same question for 16. And since my answer is no, I'll say 80, because that's 16 times 5, over 3 cookies. Now, I always say we avoid decimals whenever possible, right? But here, it probably is appropriate to get a decimal because you're wondering how many cookies you could make. Well, as a mixed number, this would be 26 2/3, or 26.67 cookies. That's rounded, of course. So your real answer wouldn't be 27, and it wouldn't be 26 2/3. You'd probably be like 26 and round down in this real-world problem. So we'll move into more algebra-looking problems with these. Hopefully that one clicked.